Alright, what's going on there, world? Facebook, YouTube, wherever y'all are out there. This is Veal once again, president of It's Not Complicated Tutoring, and I'm actually still with my client, Scott here. We're looking at complex conjugates now and polynomials. These problems can actually get kind of long, so this one problem may take up the whole time I need for the video at 12 minutes or so. If not, definitely two of them will. Some of you guys out there probably will get confused. Don't really know what complex conjugates are. First of all, what is a conjugate, right? A conjugate is something that's like the opposite of what you have. Like, if I have 5i, then you have negative 5i. If I have a plus bi, you have a minus bi. All you're doing is you're changing the symbol of your particular item. Okay? So if I have x, you have negative x. They're conjugates of each other. They're total opposites. Alright? What I have here on the board, it says complex conjugate, b does not equal 0. Obviously, because if b equals 0 in the statement a plus bi, we wouldn't have an expression anymore. It would just be a. It doesn't make any sense. That's why we can't use 0. Okay, a plus bi is a 0 of polynomial with a real coefficient. Basically, it's saying if a plus bi is a 0 of polynomials with real coefficients, that means that a minus bi is also a 0 of the function. You can't have one without the other. It's like peanut butter and jelly. It's like yin and yang. You know what I'm saying? It's like a car with no wheels. You know what I'm saying? You can't roll. You can't roll with it, right? It's like with no swag. It just does not mix, right? So here we go. The problem says
write a polynomial function of minimum degree in standard form with real coefficients whose zeros include -3, 4, and 2 minus I. Kind of a lot to say in a nutshell, but here's the deal. Here's how we knock this out. Alright? First of all, standard form. If you didn't know what standard form of a complex number is, it's a plus bi, where the b portion is the imaginary side. The a side is the real side. Alright? First and foremost. Now, the zeros include -3, 4, and 2 minus I. Now, x, that means that if I solve for x, I'm going to get this -3. So it's going to be x plus 3 is one of my factors. If I solve for x, I'm going to get x equals 4, x minus 4 is one of my factors. Now, if I get, these are my real numbers. These are my real coefficients. Okay? Now, if I have 2 minus I, I must also have 2 plus I somewhere. So, these are also zeros. So, 0, 0, 0, 0. They all cross the x-axis to give my polynomial a 0. Any questions so far? Does that make sense so far, sir? Huh?
It's crazy.
It's very interesting. It's going to get even more interesting in about 2 minutes, okay? So, here's the deal. I'm going to leave my x plus 3 times x minus 4 over to the side. This goes over to the side for a minute. What I am going to work on, though, is the 2 minus I and the 2 plus I. So what I do is, you always, first of all, you have 2 minus I in the imaginary portion, you always do the conjugate up front, so you know where to go. But furthermore, we do it like this. We do x minus 2 minus I in parentheses. Alright? Then we do x minus 2 plus I in parentheses like that. In brackets. Okay? So, to work out our polynomial, we're going to have x plus 3, x minus 4, x minus 2 minus I, x minus 2 plus I. I don't care what nobody tells you, it's always x minus right here. This right here, always is a minus sign. Okay? Does that make sense?
Always a minus sign.
Always a minus sign. Outstanding. So, here, what we're going to do is then write it all together. Alright? We distribute here
the negative through. Don't leave this negative off or you're going to jack your problem straight up. And I don't know about you, but I'd be pissed off if I did a problem this long and made one minus sign error and had to erase that mug all over again. So, x plus 3, x minus 4, and then x minus 2 plus I, x minus 2 minus I, all in one thing. Alright? Now, Scott, here's what I'm going to do. I got to find my polynomial, right? So guess what I'm going to do? I'm going to group these two, multiply them together and for them. I'm going to group these two, multiply them together and for them. What's the foliage of this right here, the first two?
The first two, x squared
Okay.
plus 3x.
Well,
Oh,
minus
I mean
4x
minus 4x.
plus 3x,
Then
which is minus x, right? Then what?
plus 3x or
No, here's 3 times 4. It's the last. Minus 12, right?
oh
Okay. Now, do you see what I'm saying? Do you see
yeah,
first, outside,
inside, last.
last. Okay. Now, on this one, for all you out there, let me give you a minute to write that down, if you need to, because this right here is about to get crucial. So, 1 minute to write that down. I'm gonna erase most of it, and we're gonna start from scratch again. This is one of them problems. I need 2 of them boards. You know what I mean? Like I need a board to cover the whole wall. Reminds me of my calculus class that I teach, and we had a problem or two that took up like 3 pages just for 2 problems. Like that's not a good look. If you make a mistake, you have to kill yourself. You know what I'm saying? So it's kind of crazy. But give you a little bit of time to write that down, and once you got that, I'm gonna erase most of it except for the x squared minus x minus 12 and the x minus 2 plus I, x minus 2 minus I. I'll go from there. You got it?
Yeah, I got it.
Okay. So, here we go. So we're continuing from here is what we're doing. We're going to go back up to the top and continue. Now, x squared minus x minus 12, and then we fall here, okay? So this goes to every single one of these guys, distributes, okay? X squared minus 2x minus ix, okay? Now, this one goes next, okay? 1, 2, 3. Minus 2x plus 4 plus 2i. So guess what's next? These 3, right? 1. Actually, you know what? I might want to kind of color code that. 1, 2, 3's next. There. And beforehand, it was 2, 2, 2 there. Alright, so we'll color code it. You can see what you're doing. Alright, the last one we do was, now we do I plus ix, and then minus 2i minus I squared. Now, that's long, right? Sorry about that. Didn't mean for that to happen. Okay. So basically, we have a long problem here, don't we? How do I simplify that? That's gonna be the answer. That's the $1 million question right now. Is how do I simplify that and solve for this thing, right?
You could add like terms.
Yes, combine like terms. But before I do that, Scott, here's something you have to remember. When you learn when you learn complex numbers, I squared is a special number, sir. Facebook world or YouTube world, wherever, y'all out there, what do y'all think it is? What do y'all think it is? 2? Could be 3? Could it be 5? I squared, my friends, is actually -1. Okay? I squared is -1 because the square root of -1 is I. Okay? So, here we go. Like Scott said, we have to combine like terms. So x squared minus x minus 12. Combine here, right? Combine here. Combine here, right? And leave those alone. Does that make sense? Those actually combine to each other like that. So if we look at this, kind of looks like a hot mess. But x squared minus 2x and minus 2x gives you what? What does it give you? Minus 2x and minus 2x, sir.
Oh, minus 2x and minus 2x.
Minus 4x, right?
Oh, minus 4x.
Okay, now what?
Combine the other ones.
This cancels out, right?
Mhm.
What's left?
4 and -1.
Okay. So 2i and -2i cancel out too, right?
Yeah.
So yes, 4 and minus a -1. But a negative and negative is a
Positive.
so 4 plus 1 is
5.
so it's gonna be plus 5 right here, right? So x squared minus 4x plus 5. Now guess what we gotta do? We get the luxury of multiplying all of this out now. Wow. Okay. So I'm gonna erase all of this over here. And we're gonna follow up on this problem. So the first thing we do is distribute here, here, and there first. Would you agree?
So we're yeah. I agree.
First one, right? First one goes to all three, right?
Yeah.
Then the second one goes to all three. The last one goes to all three, right? So x to the 4th minus 4x cubed plus 5x squared. Oops. I'm dropping my eraser. It's not a good look. Okay. 5x cubed. No, 5x squared. Well, I may have to continue this problem. So that looks like that was my timer, y'all. So let me continue this problem right there where we left off. All right.